Hey, how you doing, kids? Good afternoon, evening, morning, depending on when you tune in. I want to run through the PopGen Fishpond lab that you're doing today, which is Friday. No, Thursday. Thursday. Oh, gosh. It's tough when you record these videos on different days and you actually need to show them. You're going to be seeing this on Thursday. So the procedure is here, and this is all in the Google Doc that's attached to the lab. There's a link there as well to get you to the lab activity. And there's a link here that will get us there as well. So we're doing the PopGen Fishbowl. I want to get these to both fit onto the screen. So we're going to resize this stuff a little bit. Not what I wanted. There we go. That'll work. So we've got the lab activity here, and the procedure is all there. I apologize that it doesn't totally fit on the screen now, but we get the idea. I can reduce this a little bit, maybe. Make that like 90%, 75%. There we go. We get the gist at that point. So it starts off with background information, and the lab does have this background section here. And that's kind of where you want to start off at. It does talk about population genetics and Hardy Weinberg, who came up with all of these ideas. It talks about how modern theory of evolution is a little bit different from what Darwin had in mind when he came up with this. Click next, and it runs through all of this evolutionary mechanisms. This particular lab, we're going to be dealing with migration, mutation, and selection. Concepts that we may or may not have talked about in the past. We definitely talked about mutation. We definitely talked about selection. Migration, not as much. I know we've covered it a little bit, but not really in depth. We will in the next unit, though. So we're kind of setting ourselves up for our ecology stuff. Selective breeding we definitely talked about, but koi genetics is the big thing. This is a koi pond that is being simulated. Those are those big Japanese goldfish. They are, in this simulation, 3 colors, depending on the genes that they have. If they have 2 recessive genes, they are white. If they have 2 dominant genes, they are red or orange. And if they are heterozygous, having 1 dominant and 1 recessive, they are spotted. And we've all sort of seen pictures of these fish if you haven't had the ability to see them in real life. Come back to the home, and it runs you through the tutorial. This is not a bad place to go to be familiar with the controls that are here. And it'll introduce you to what's going on, and you can see the pond environment that we're going to be working with. And you can hit next, and it tells you about that pond. And then you hit next, and it tells you about your controls that are over here. It talks about the demographic controls. These are going to be our constants, and so we're going to keep them set at where they are when we begin, which is 200, 200, 0.5, 10, 10, 0.5. And I'll talk about those a little more specifically in a minute. Then you've got your evolutionary parameters, your migration rates, your mutation rates, and genotypic relative fitness. And we have control over all of those things. Migration is exactly how many fish swim into the pond. You see that there's a little river that comes to the pond, and the fish will come in through there. And then we get to determine what the fish look like based on the alleles that they have. We can control the dominant phenotype that's here. Mutation rate is the dominant mutating to the recessive mutating to the dominant. We get a little bit of control over that. And then the genotypic relative fitness, we get some control over. And that's how easily is there an advantage, let me say it that way, is there an advantage to having one genotype over the other? Is there an advantage to being, red versus white or having spots? Assortative mating we're not going to deal with. We're just going to leave that at 0, and I don't really mention it in the procedure at all. Our data is this little arrow here. You can click over. to go to your data, and it shows you about the graphs that you see, your population size, genotype proportions, allele, and then your data table. Final instructions, we've got our time controls here, the play, the fast forward, and the rewind. Rewind doesn't take you back in time, it just slows things down. The lowest you can do is 1 times. The highest you can go is 16 times, and I recommend that. If you run the simulation at a 16x time scale, each simulation will take you about 45 seconds. If you set things up so that you can conveniently enter data into your table and run the simulation so that you're not doing a lot of switching back and forth, it should go pretty quick. It should take you about a minute and 15 seconds per trial that you do. And you're going to be doing 12 trials, so 15 minutes is what it should take to actually do the lab, and then you have to answer the questions. So it should be able to be done in 45 minutes, which is 1 class period. Great, so we hit next, and it actually starts our simulation. Problem is, things are not set the way we need them to be necessarily, so we want to go and pause this, and we want to reset, and all your fish will bunch up. And now you can go through and look at your experimental design and evolutionary parameters. If we look at this procedure, we've answered our background. We should make 3 hypotheses, and then we're told all about doing this 12 times. Down here we've got our control trials, and this is where we're at. This is our first step here. So our initial size should be 200. It is. Carrying capacity 200, it is. Sex ratio, male to female, should be 0.5. That's 50%. Anytime you see ratio or proportion in their decimals, we can easily change that to a percentage by moving our decimal 2 places to the right. So 0.5 is 50%. Mortality rate of 10, brood size of 10, meaning the same number of fish are being born every generation as are dying every generation. Okay, that should give us a nice stable population. Our initial dominant allele proportion should be 0.5, and this is 0.5. Once again, that's 50%. Our evolutionary parameters, migration should be 0. Our allele, which is our dominant allele proportion, should be 1. Remember, that proportion of 1 is equal to 100%. If we move our decimal over 2 places to the right, 1, 2, you can imagine the zeros there. We're adding 2 zeros to the right of the 1. That makes 100. Mutation rate should be 0. Both R to R, big R to little r, and little r to big R. Both of those should be set to 0. Our genotype relative fitness is all 1s. Okay, meaning 100% of the individuals that have those genes should survive. Once we've got that, we're going to run the simulation out to 100 generations. We're going to record the data on the table below, which is down here. And then we're going to hit the reset button at the top right. Here is our reset. And then we're going to repeat that 2 more times to get all of our trials. So let's see what this comes out to be. I'll enlarge this a little bit and pull it over for us. So we're all set. I'm going to hit start, and the fish start swimming. I'm going to go over to my data, and we can watch these graphs get built. We can watch the numbers change. I'm going to speed up my time and make the fish go crazy. And we're going to count out the generations here. It does go pretty quick. It may seem like a long time at first, but after you do a few, it's less than a minute per run if you run it at 16x. What I like to do is run this out until I get to about 90 and then start slowing the speed down. Okay, I'm at 83, 85, 6, so there we go, 90. If I go down to 4 times, it's not kind of reasonable. 96, 97, 98, 99, 100, and stop. Okay, so there we go. All of our data is here in this data table. We can look at our allele proportion, and we see that it went up a little and then drop down, and it's working its way back up. If we look at our genotype proportions, the homozygous recessive, homozygous dominant are relatively equal. The heterozygotes are larger, and that's not what we would, that's not far from what we would expect. Our population size did stay pretty constant. We started with 200 fish, we ended with 194. So we lost a few, but not super a lot. I'm just going to slide this over, not that far. And now I can move down to the data table. Entering the data should be pretty simple. I've got data from my trial here, my trial. And so it should be pretty simple. Our population size, we enter that in, is 194, so we 994, and you just tab across, is 0.49. Do not forget those are decimals. Make sure you put them in. 0.51. Notice that that adds up to 1. 0.49, 0.51, total up to 1. You'll see the same thing with these three. They add up to 1. And that's part of that Hardy-Weinberg equation that you saw in the textbook yesterday, and that was part of the extra credit as well. 0.27, 0.48, and I accidentally hit an enter in there, and 0.25. Great. So I've got that. I can now bring this back, hit the reset button, and all of our fish go back, and then hit the play. And all of our parameters will go back to where they were started, and we begin again. Our graphs start over, all three of them, and we keep going. Before I speed this up, what's really neat about this simulation is you can see there's little itty bitty baby fish, and there are big adult fish. Here is that stream that comes in where we would get migration from. The baby fish all come from under this lily pad here, out into, and then as fish live their life, they will sort of just disappear from the simulation. But they swim around and it's kind of fun. It's sort of relaxing to watch. We're at 30 generations. I'm going to speed up time here till we get to 16. And run it out to 100. Okay, slow down when we get into the 90s. 97, 98, 99, 100. Pause, and then we want to look at entering that data. So our population size is 200. And what happened? Need to move over further. 0.45, 0.55, 0.32, 0.45, 0.23. And so you can see we're pretty consistent with our numbers. If you get an outlier, you get an outlier. That's why we're doing through trials. That's why we're taking an average. Okay, that's all in your procedure. I'm not going to do all three of them, and I'm going to delete this data before I forget. Next step of the procedure is to go to the migration trials. And so you need to go back to design and leave all of your population dynamics the same. These are constants for our experiments. But we're going to increase the migration rate. You can control it with these arrows here. We can make it go up. We can make it go down. The procedure tells us to bring it to 0.7. And we leave that. We leave our migrant dominant allele proportion at 1. And that's all well and good. And then we can start our simulation. We need to hit reset. Start the simulation, and the fishies start swimming around. But now you see they are migrating in through the stream up here. And we can make it go faster, and we can switch over to data to make sure we don't go past our generations. Okay. The rest of the lab pretty much follows that same procedure. You run through, you hit your pause. Notice how, in this case, things are changing a lot. We see a large number of those dominant alleles. Population is still pretty consistent, but our allele proportion on this graph is going way up in favor of that dominant allele. And there we go. I went over by 1. it's probably not going to make a big difference. Our population size is 196, 0.98, dominant allele proportion of 0.02. No recessives anymore. We don't have any white fish in that pond. We've got a very small number of the spotted fish and a lot of those dominant recessives. And so we would fill that out on the data table. Down here in the migration trial 1 and keep continuing. The procedure is there. It's pretty clear. Read the directions if you're not sure. And then once you're done, there are 9 analysis questions you need to answer. Okay. You are being graded on the 5 background questions, the 3 hypotheses, and those 9 analysis questions, and a complete data table. You got to have all that stuff for the lab. Okay. Hope this is helpful. Hope it smooths through any questions that you might have before you have them to make this a little easier. So good luck. Have fun. Look at all the pretty fishies and stay healthy. I will talk to you again next time. Bye-bye.